Hi everyone, it's Mrs. Summer here to discuss Lesson 114, Chemical Reactivity Trends. The goals of this lesson are to identify the reactivity trends on the periodic table, rank atoms based on the reactivity pattern, and predict the reactivity of an atom based on its location on the periodic table. Reactivity is how willing an element is to have a chemical reaction, whether it's gain or lose electrons with other elements. React by gaining or losing electrons. The easier it is to gain or lose electrons, the more reactive they will be. There are two different trends on the periodic table, the metals reactivity trend and the non-metals reactivity trend. Metal reactivity across a period. Look at these two elements, lithium and beryllium. What is the difference between the two? Lithium has one valence electron, and beryllium has two valence electrons. Lithium only needs to give up this one electron to have a completely filled outer shell. Beryllium needs to give up this electron and this electron. So lithium is more reactive than beryllium because it only needs to give up that one. It's really, really reactive because it only has one electron to give up. So by giving that up, it's happy, it's full, its octet, or in this case, its duet, is completely stable. Beryllium would have to give up this, which is still reactive, but then it still has this one extra electron to give up. Well, then it's going to have to react that one too. But the whole point of reacting is to make its octet full. So the metal reactivity increases as you go across. Non-metal reactivity, if you look at across the period, the reactivity for nonmetals increases as you go across the period. Comparing oxygen to fluorine, oxygen has 6 valence electrons, while fluorine has 7 valence electrons. How many more electrons does fluorine need to have a full octet? Fluorine only needs plus 1 electron. It only needs one more, so it's going to grab that electron, and it's going to take it probably from sodium or cesium or any of the group 1 elements because they're easily giving it up, whereas fluorine is going to take it. It's going to react very easily. Oxygen, still highly reactive, but it's still now it needs to get 2 electrons. So fluorine is more reactive because it only needs 1 electron to be happy, whereas oxygen needs 2 additional electrons to be happy. For the nonmetals reactivity up a group, the reactivity increases as you go up a group because for a similar reason as to why the reactivity of metals increases as you go down, it's the reason why nonmetals, the reactivity increases as you go up. Because fluorine, this positive nucleus with the 9 protons, well, we have another electron coming over here, and there's a less distance to shield this pull. So this electron that's coming in from group 1, it's going to see this positive nucleus, and it's going to want to come over and react. But iodine has a greater distance between its nucleus and its outer electron. So if you have a valence electron coming in over here, it's not going to feel the pull of those 53 protons because there's too many energy levels shielding that nucleus. So here you try. Order the elements in order of reactivity, the least reactive to the most reactive. So your first set is calcium, beryllium, barium, magnesium, and strontium. Second set is sodium, aluminum, and magnesium. Third is carbon, oxygen, and nitrogen. And your fourth is astatine, nitrogen, and phosphorus. So here's the key for number 1, from least to most reactive. beryllium, magnesium, calcium, strontium, and barium. Your next set, aluminum, then magnesium, and then sodium. Third set, carbon, then nitrogen, then oxygen. Fourth set, astatine, phosphorus, and nitrogen.